What up nerds, Machina here, and today I'm gonna make this mini fridge that's perfect for a desktop or maybe a camping van. As you can see from the sketches, I'm not having it stand upright, and this is because the cold air will just flow right out every time I open the fridge, but with this design and the lid on top, most of the cool air stays inside the fridge and it doesn't take long to cool it down again. The first thing I had to deal with is this styrofoam insulation that would make the whole inside of the fridge. The first shape I created was this one, which would be the main room. It should be big enough to fit 5 half-liter bottles. So I'm just gonna measure up my pieces and use a styrofoam slicer to cut it. I built this styro slicer mainly for this purpose, and I'll probably need it later anyway. It's an awesome tool and it cuts foam and styrofoam like butter, and it's easy to use. If you want to know how to build this tool, I'll leave a link to King of Random's video on how to make it in the description. This particular styrofoam is very thick, so I had to split it in half. I just pushed it against an angle and then the cut became straight. When I had all my pieces for this compartment, I had to glue it together. I found this glue called Multibond that in addition to gluing also fills any small gaps, and it works on most materials. It had to dry for a couple of hours before I could deal with it further, so in the meantime I had time to cut and split some more styrofoam that I could use later. I also had time to make a bottom piece out of MDF. I began cutting a square that would fit my measurements, and then I had to cut and drill some holes in it. Firstly, I drilled 4 holes in each corner for each of the legs. Secondly, I had to find out where to cut the holes for the fans, so first I had to cut some holes in the styrofoam where they would enter the main compartment. This was easily done with a utility knife. I made sure to make extra space around them on the inside. Nice, the fit looks pretty good. I just have to make one more cut in this piece before gluing it on. This will make room for a snack shelf right above the cooling modules. I glued it on, making sure to get the multi-bond into all the cracks to avoid any air leakage later. Now that I had the proper placement of the fans, I could finally mark them up on the MDF and cut the center circles out. That was quickly fixed with a drill and a jigsaw. The warm air from the fans will now be able to escape through the holes on the bottom. Here are the legs I used, which are actually just knobs for cupboards. I'm gonna use a couple of other aluminium parts in this build that will match this, and I think that will look pretty good in the end. I fastened all the legs and now onto the lighting. I wanted the fridge to light up whenever I open the door, and therefore I need some lighting that's well incorporated in the design, and these angled channel holders for LED strips will do perfectly. I just used a tiny piece of styrofoam to cover the top, and I could cut them to the right size with a hacksaw, and as always, you'll find a link to everything in the description. I chose to use regular cold white LED strips for this and attached a couple of long wires to it. I could then cut it to size, glue it on and cover it with a plastic top. The wires needed a path to the outside, and the soldering iron did the job. Before attaching the LED channels, I added this aluminium tape to the corners. This will cover the whole inside eventually. I pushed the wire through the hole, glued the channels to the corners, and then the tiny styrofoam piece at the top. Finally, not forgetting to push as much multi-bond as I could into the hole to prevent any air leakage. As you can see here, I'm just making some paths for the cables so it will sit flush against the MDF when I'll glue this whole compartment to the bottom. Now let's see what the lights look like. Nice, now I can glue the whole piece to the MDF. Awesome, this part is done, and now let's move on to this part where I'll deal with the electronics. Okay, so these electronic refrigeration modules have too many cables going in every direction, and I have to clean that up. Shrink tubes will do the trick and keep everything in order. There are 4 black and 4 red wires on each module, and I added a terminal like this at the ends of all of them. Here's what they look like when they've been cleaned up. At the opposite end of the terminals, I added another cable that will extend to the thermostat, and at this point I could fit the modules in place and screw them to the MDF. There was a tiny gap at the bottom, and to make sure that all the warm air flows through to the bottom, I added some tape and some hot glue around them. I also hot glued the foam around here to the styrofoam. It's time to hook the modules up with the thermostat, and I've made a schematic that looks like this, which you also can find down in the description. I hooked up both the modules and a separate cable that will go to the power supply. As you can see, I'm splitting that wire in two like this, so the power supply can power both the thermostat and the modules. All of them are connected to a common ground. It's shown quite clearly on the schematic. It all works, which is awesome. The placement of the thermostat is just temporary, by the way, I moved it later. I cleaned up the cables further by covering the wires from the LED strips and the thermostat with a long shrink tube. And okay, let's move on to the power supply. This is the cable that will be the main power source for the fridge, and it will go to a power inlet of the same type that's used in computers and computer screens. I stripped the wire and added this wire terminal that's easy to connect to the power supply. Here I've hooked everything up to the power supply, and I ended up adding a switch to the LED strips later, which you can see in the schematic. By the way, in case you were wondering, the power supply I'm using is an AC to DC 12 volt 16 amps power supply. You can find it down below. I also made sure to place the sensor of the thermostat inside the main compartment close to the bottom before continuing. Let's move on to the snack shelf. I just made sure to get the right measurements, and then the same process went here with the styro slicer and the multi-bond. And to give it some more support, I added two tiny pillars to keep it in place. Now that the whole styrofoam shape is finished, I could cover the entire inside with the aluminium tape you saw earlier. The whole thing will be covered with 5mm acrylic glass, and I used this scoring knife to make nice and straight cuts. When I thought the cuts were deep enough, I could line it up against the edge of the workbench and give it a hard push with a plank to make it break, and it worked every time. Here are all the pieces that I'll cover the sides. I wanted our channel name on the front, so I downloaded the font I wanted, typed in our name and made some small changes in Photoshop before printing it out. I should have printed one regular and one mirrored version, and you'll see why in a second. I'm gonna make these pieces right here, and I gotta deal with the text and patterns before painting, so I'll be using white sticker paper to make all the patterns mirrored and stick them to the inside of the acrylic pieces. This way the outside surface is plain glass and that'll look shiny and be easy to clean. I cut out all the letters mirrored, and this is where I should have had the mirrored printed version because it would be easier to line up the letters. I managed to tape them on correctly anyway, so it wasn't a big issue. As a final touch, I'm adding some wave shapes to give it some more detail. On the back I needed to include some air holes to let the air through. I made a grid and drilled holes at every cross, and I thought this would suffice, but later I figured out I had to include holes on the left and right sides too to keep it cool enough. If I had known that, I'd do that at this point. I clear coated it first, and when it was dry I had to paint over the stickers with white acrylic paint because they were a bit transparent. When I was happy with it, I used red spray paint for automobiles to cover it up, and finally a thick layer of clear coat. While the paint dried, I could prepare the fridge for gluing. At the top I removed the aluminium tape to further prevent the cold from escaping. I also added more tape to the outside for insulation. On the front edge I added 4 magnets that will push the lid down, and covered it all with white tape. Now I got the plug I needed in the mail, and so I can mark it up and make a hole for it. The smaller hole on the left will be a power socket where I can connect a 12 volt power supply, like for example a car battery. This other one, which I'll use more, is the AC input. I'm also making a hole for the thermostat display. All I have to do now is attach the front and side pieces and let it dry. I'll make the back piece detachable so I can access the electronics. Overnight I tested 4 different types of glue, and after pulling them apart, only one was standing, so that's the one I'll use. It's glue meant for plastics like acrylic. I fixed up a couple of angles with a spacer and a nut and glued those with strong metal epoxy, making sure not to get any on the screw. In the meantime, I can cut some aluminium angles with a hacksaw and glue them to the acrylic front with plastic glue. When the metal epoxy had dried, I could remove the screws and glue the angles to the inside of the box. With a piece of large paper I could mark the holes and drill them in the acrylic back piece. It fits, and I could add the angles here too, only glue on the back though. I added another type of terminals to the wire on the AC input. These will be easy to connect to the power inlet, and they're fixed firmly in place with a crimping tool like this. Now I can just insert both my power inlets and hook them up with their wires. The thermostat is supported by these spacers, and I made sure I was able to see the display from the other side when gluing it on with hot glue. The lid will be kept in place by some hinges, and I just have to make space for them at the top right here. To remove mass, I used my Dremel tool and finished off the shape with a file. When I had the right fit, I could glue it on with the plastic glue I showed you earlier. The lid I'm making will consist of 2 pieces of acrylic attached together with double-sided tape, and I quickly cut 2 pieces and drilled holes for the hinges on one of them. As I did on the front, I wanted the logo on the lid too, but this time I used our silhouette to cut it out instead of using the scalpel. As shown already, you don't need this tool, but it does make cleaner cuts. I attached the letters on the bottom layer of the acrylic, so it sits inside the air seal between them. And finally, I added the double-sided tape and the top acrylic piece, drilled the holes through, and the lid is finished. To really seal the lid tight enough, I used this self-adhesive rubber seal meant for sealing doors and windows. Then I added some magnets on top of the other ones that I could cover with glue before putting on the lid. The lid was fastened to the hinges with screws, spacers, and nuts. I made sure to remove the rubber seal underneath the screws to really make it airtight, and then I glued on an aluminium door handle. And this is probably my favorite part, which is peeling off the plastic. The only thing left for me to do was to hook up the momentary switch button that I'd got in the mail. I hooked it up to be normally closed, so whenever I open the fridge, the lights will turn on, and whenever it's closed, the lights will be off. And that means I'm actually done. So I've been using the fridge for a while now, and it reaches about 6 degrees Celsius in 30 minutes without anything in it. When there's something that has to be cooled, it takes a little while longer, and the other way around, if you put something cold in it, it cools down faster. The thermostat saves some energy, but I wouldn't consider this particularly energy efficient. But I imagine it's something that could be useful on a desk or on LAN parties, or LAN parties. And in a camper van, for example. If you really pay attention to the insulation, I think it's possible to get a decent energy efficiency, and I probably could have done more to really optimize it. Overall, I think it's a nice mini fridge that works well, and I probably use it on occasion, for example while working long hours in the workshop or in front of my computer, but I probably won't leave it on permanently. If you enjoyed this build, click the sub button and let me know what you thought of it in the comments. Thank you so much for watching, I'll see you in the next one.